All right, folks, on to the second half of our notes here. So the second half is just talking about how to convert between polar and rectangular to polar. So this is just going back and forth between the two different graphing systems. So if you have r and theta, so if you're in polar coordinates and you want to turn them back into the old x and y that we learned how to graph in middle school, we use these two formulas. So I know r and I know theta. I would plug those in, and then I'll get a value for x. Then the same thing idea over here. I'm going to plug in r, I'm going to plug in theta, I'm going to do the sine of that, times it by r. That's going to give me my y value. And then the opposite direction here, when I got the x and the y, so I've got it back in our old coordinate, Cartesian coordinate system. If I want to turn it into r's and thetas, radii and rotations, then I use these two as my formula. All right, so let's jump into, I'm going to do one, and then I'll encourage you to pause and try to do one on your own, and then we'll do the same down here. All right, so we've got convert from polar into rectangular. So this is r and theta. So I have r and theta. That means I want to turn them into x and y, so I'm going to use these two formulas. So my first formula is x equals r, in this case negative 2, times cosine theta, which is pi over 6. All right, now in the past, kids have been tempted to just grab their calculator and type this in. You're going to get a real messy decimal most of the time here. This is something that we can evaluate, something we learned at the very beginning of this semester, cosine of pi over 6. So I'm going to count around to pi over 6. That's 130. Now I'm going to take that triangle, I'm going to blow it up. Right angle, I've got a reference angle of 30 degrees. All right, so if this is the 30, opposite the 30 is 1/2. That's a 30, so that's a 60. Opposite the 60, square root 3 over 2. Do I have any negatives? Nope, we're in quadrant 1. Okay, so now I can come back up here. Negative 2 times cosine of pi over 6. This is the pi over 6 triangle. Cosine is the x side, so that's the square root 3 over 2. Do a little cross multiply, make that into a fraction. Those 2's are going to cancel, and I'm now left with negative root 3. Okay, now we're going to do the same thing for y. My y coordinate is given by r times sine of my rotation. Sine of pi over 6, luckily it's the same triangle. Sine is the y side, or the opposite side, so that's 1/2. Negative 2 times 1/2 is negative 1. And now we take these and we put them together in a coordinate pair with x and y. So my rectangular coordinates are x and y. All right, I would encourage you to try to do part B on your own. So hit the pause button and go after it. All right, hopefully you took care of that. Let's see how you did. So yet again, I've got r and theta. I want to turn it into x and y, so I'm going to follow these two formulas. You can put these on your unit circle for those who are taking AP Calc. If you want to keep all your formula stuff organized into the same place. So I've got x equals r. This time is 5. Cosine of my angle is negative 4 pi over 3. Uh-oh. We just got done with the school day. 5 times, all right, cosine, I've got to figure out where that angle is. So I'm going to do a rotation of negative 4/60. 1, 2, 3. There's my triangle, and blow it up so that we can see it a little bit better. Right angle, my reference angle is 60 degrees, which means opposite the 60, square root 3 over 2. That's the 30, so opposite that is 1/2. Any negatives? Yes, sirree. That x is negative, going backwards. Okay, so now it's plugging and chugging. Cosine is the x side, so that's negative 1/2. 5 times negative 1/2, we make that into a fraction, multiply straight across. We get negative 5 over 2. Then our y value, 5 times sine of negative 4 pi over 3. 5 times sine is the y value, square root 3 over 2. Turn it into a fraction, multiply straight across. I wouldn't try to make that look any nicer than it already is. So now I'm going to take these two values and I'm going to record them as rectangular coordinates. My x is negative 5 over 2. My y is 5 root 3 over 2. And I'm going to box it in, put it up on my fridge. So it's going to be tempting to grab your calculator and just type those in. Nah, you don't want to. You don't want to. All right, so let's go the other direction now. So now we're going to start in rectangular. So we already know. I just went from blue. Let's try purple. This is x. And this is y. So now I'm going to use these conversion rules. Also can put on your unit circle just for safekeeping if you want to. So I'm going to first figure out r squared is equal to x, negative square root 3 squared, plus y, 3 squared. Notice I put my parentheses around it to remind myself when you square a negative, it's going to become positive. So let's see, negative root 3, so the negative is going to square out, that's gone. Square root of 3 times square root of 3 is 3. Plus root 3, or 3 squared is 9. 3 plus 9 is 12. Why isn't 12 my radius? That's because this is still r squared. So now I want to square root both sides. All my colors are at home. And I guess this will have to, no, let's go with pink. So square root is on fire. We don't need no water, we just need a plus or minus. Now don't forget how we handle a square root of 12. That's not a decimal. We clean that sucker up. All right, what perfect squares go into 12? 4 times 3, obviously. So the 4 gets to escape, becomes a 2. This 3 is left inside. Now notice, I'm not going to box this in yet, because when you have a coordinate pair, you can't have both of these. It has to be the positive one or the negative one. And so we're going to do a little bit more work to figure out the angle. So I'm going to go now to my angle formula, which is tangent of theta equals y over x. So for us, that would look like tangent of theta equals y over x. Right away, I don't like two things. I don't like that there is a negative on the bottom, and I don't like that there's a root on the bottom. The negative on the bottom I can just bump to the top. The root on the bottom, remember, we clean up with multiply by root 3's. So then this would end up being negative 3 root 3 over root 3 times, I just bumped that negative up. Root 3 times root 3 is root 9, which ends up being 3. And then notice what happens. Those are going to, 3's are going to cancel, and I get negative root 3. Now that's not what theta is. That's what tangent of theta is. So this is where we go to our unit circle. Remember how we used to do this with the old check marks? Tangent is negative. Check and check. The tangent that is square root 3 over 2 is 60, isn't it? Okay, so the two 60-degree triangle. Now this is where I'm going to tie this back into the plus or minus. So I'm going to start with this original point and make kind of a sketch. I don't care exactly where it is, I just need to get close. So negative root 3 is going to go back on the x. Positive 3 is going to go up on the y. So my point is going to be somewhere up in here. Now we want to compare this to our angles down here. Now you can use either one. You can use either one of these check marks, but which one you pick is going to tell you what your radius is going to end up being. Now I usually just pick the check mark that's in the same quadrant as the actual point. So the point's here, the check mark's there. So what 60-degree angle is in that section, that's going to be my 2 pi over 3. Okay, 2 pi over 3, but do I want to go, so 2 pi over 3 is up here. Here's the origin. Do I want to go towards my finger, towards the angle to get the point, or away from it? Obviously, I want to go towards it. How far do I want to go towards it? This radius here. So that becomes my x value. Sorry, my radius value. Or you have two options here. You have two acceptable answers. So I chose to use the quadrant that the point was actually in. I could also choose the quadrant across from that. So who's the 60 in this section? That would be 5 pi over 3. By the way, you could also write negative pi over 3. Those are all the same thing. But this time 5 pi over 3 is down here. There's the origin. The point is towards the angle or away. Obviously it's away. So I would choose the negative one of the plus or minus. So this is negative 2 root 3. All right, you try the next one on your own. Hit a quick pause there, and then we'll discuss it together. All right, let's see how you did. I don't have enough colors. This is x and this is y. I'm going to start off by calculating r. So r squared is equal to negative 7 squared plus negative 7 squared, which equals 98. That's not what I want, though. I want r, not r squared. So I need to square root both sides of this. Square root, square root. I'm going to bust this over here. What perfect square goes in? Oh, 49 does, because there's two of them. So that's 49 times 2. The 49 escapes, so r is equal to square root, square root. We don't know any plus or minus. The 49 escapes becomes the 7. And I've got the 2. All right, so I'm going to use one of those. I don't have to do both like I did over here, but I'm going to use one of them. And I can't do that until I figure out the angles. So now I'm going to move on to tangent using the formula from up above. Tangent of theta is equal to y over x. Negative 7 divided by negative 7. Tangent of theta is equal to positive 1. All right, tangent is positive here and here. Check and check. Tangent is 1 at the 45s. So I'm looking for the 45 degrees in this section. Now, the way you decide this is based on where the actual point is. So now you want to go back up here and do a quick little sketch of where negative 7 would leave you. Negative 7 would leave me somewhere down there. So the actual point is in this quadrant. So now I'm going to compare this to this. There's two possible acceptable answers. So that the angle, the 45 that's in quadrant 3, just like where the point is what? 1, 2, 3, 4, 5 pi over 4. Remember, you could also use negative 3 pi over 4. Those are the same place. Okay, so 5 pi over 4 is down here. From the origin, the point is down there, so I want to use the positive version of the square root of the radius. Or I could use this quadrant, which the 45 in that quadrant is pi over 4. I could also do negative 7 pi over 4. That would take me up there as well. The angles here, the point is across from it, so I want to use the negative radius to get that result. Now, you don't have to write both of these. You can pick one or the other. What do you think? All right.